Hi, welcome to the physics course selection info session. I'm Mr. Lorden. I'm one of the physics teachers here at Monte Vista High School. Ms. Choi also teaches physics here at Monte Vista High School, and she wishes she could be here. She's under the weather right now, so it's just going to be me today. So today's session is going to cover just a lot of the frequently asked questions we get about physics for students who are interested in taking the course. And so I'll address a lot of those frequently asked questions and just try to give you kind of a big picture of what you'd be looking at if you took physics next year. So the first thing I have up on the screen here is just sort of the sequence for physics classes at Monte Vista. Notable is that physics is offered to 10th graders, 11th graders, and seniors. And it's a good foundational course for preparing you for either the future courses at Monte Vista, so AP Physics 1 or AP Physics C, or for just physics courses after high school. Personally, I think it's a better preparatory class for AP Physics 1 than AP Physics C. We do have some students who will go from physics straight to AP Physics C, but I think that's a pretty tough jump, and I think I wouldn't recommend it for many students. So what are the math requirements in physics? The reason I got this slide up here is because physics relies heavily on math. And if you have a certain comfort level with math, that comfort level often translates into physics as well. Maybe more so for the AP Physics classes at Monte Vista, but it's true for physics too, that there's a certain math level of just required use in the course. For physics, you're frequently going to be using algebra. So you're going to be making graphs, interpreting graphs, and then also setting up equations, plugging in variables, and solving for unknowns. So it's a little bit of algebra, and there's some geometry in there too. But if you have a little bit of comfortability with math, you should be okay. In class, most days in class, we usually have some sort of like an observation, like a demonstration or hands-on activity where you get to see something happen. And then from that observation, you'll sort of build the concepts from that. You'll ask questions about it, you'll investigate it, and then, we'll end up with content knowledge from what we're observing in class. And then usually units kind of have this flow of after you have those concepts, kind of a little bit of a foundational concept knowledge. We'll introduce equations to describe what we've learned, and then we'll use those equations to solve calculation style questions too. I've got some sample work up from physics. You'll see there's a lot of diagrams, a lot of sketches, and then those sketches are used to generate equations, which we'll then use to solve for an unknown. Not all of the things we do in class look like this. So we have, a lot of other problems where you're just explaining something with like a CER using that claim evidence reasoning format. We've got problems where you're working on things, right, with just more words, describing things with words instead of like calculating things with values. But this is kind of an example of something like math that you might see in the course. Regarding homework workload, there's about 1 hour each week. So that consists of either watching videos to kind of get you some content ahead of the next class, or it could be finishing up stuff that we worked on in class, that week. So you could be finishing up a lab activity or solving problems from a handout that we did, or working on a project with your group. So, on any given day, it probably varies from about no homework to about half an hour. But this is kind of the general amount of time that we have working outside of class. I think depending on the student, some students spend very little time studying for the exam, and some students spend a lot of time studying for the exams. So there's kind of a large amount of variability in how much exam preparation students put in, but that would be on top of this homework that I have here. So I kind of mentioned already that there's kind of a lot of these little mini labs that the classes are sort of built on. And in addition to those in-class demonstrations and those smaller lab activities, each unit will have a larger lab generally that you're working with your group to ask questions, explore concepts, and eventually you're conducting this experiment that you kind of come up with a conclusion and you sort of link it to what it is that we're learning in class. We do have assessments regularly. I think the most notable thing here is you get equations for all of those relationships that we learn in class. So you don't have to memorize any equations, but you do have to know how to apply them, and you have to show that conceptual understanding as well. You can expect about one assessment every week. So it could come in the form of a shorter quiz on a weekly basis or a longer unit exam on a roughly monthly basis. We do understand that, every now and then you got an off test day and it just doesn't go well. There is going to be some sort of a redemptive practice for both quizzes and unit exams planned. Right now the course is undergoing some changes as a result of the remote learning that we're going through this year. So I'm not sure exactly what that's going to look like for next year, but you can expect some sort of test correction, retake opportunity following those quizzes and unit exams. And then I get this question a lot, just what are the grade distributions like? I'd say it's typical of many of the classes here at Monte Vista. Many students get Bs, and to get an A grade, you'd have to have a high level of understanding of both the concepts and critical thinking and lab skills. This is a laboratory class. The successful students in the course are often the ones that reach out for help. I see a strong trend that the students that come to office hours that are asking lots of questions, that are, regularly seeking support, that are proactive in getting that help, those are the students that usually do well in the course. And I think it's true not just of physics, but courses in general, but it is certainly true of this class. I also want to emphasize that this class it's a rigorous course. It's not an easy course by any means, but I think it's a very fun course too. It's one that I really love teaching. It's one that it's meant to be fun for the students. And, I'm hopeful that if you do take it, in the future, that you enjoy it as well. Anyway, I hope I get a chance to meet you and see you. Thanks for attending the info session, and maybe see you next year.